Hello everyone, for this tutorial video, I would like to explain the law of cosines, which is the most sophisticated in terms of how its formula is stated, but also at the same time, the most convenient to use as you only need to know one thing before you use it to solve for everything else. The proof of the law of cosines is similar to the proof of the law of sines in that you split a complicated triangle into two right triangles, and then use algebra and geometry to get the formula in its most convenient form. In particular, we would see that just like the sine of one of the right triangles is the height of the split divided by the hypotenuse of the right triangle, the cosine of one of the right triangles would be the leg perpendicular to the split divided by the hypotenuse of the triangle. And we next rearrange this so that the leg perpendicular to the split is equal to the hypotenuse of the right triangle times the cosine of the degree opposite the split. We next notice that the leg perpendicular to the split of the other right triangle is equal to the base of the entire triangle minus the perpendicular leg of the other triangle by basic definition of what a line is. We next use what we proved in the last video, namely that the sine of one of the right triangles is equal to the height of the split divided by the hypotenuse of that right triangle, to find that the height is equal to the hypotenuse of the right triangle times the sine of the angle of the right triangle opposite the split, which is what we knew in the last video. However, this fact is useful to reiterate because we can now apply the Pythagorean theorem to state that the hypotenuse of one of the right triangles squared equals the height of the split squared plus the leg of the right triangle squared that is perpendicular to the split. And we substitute in what we found with regards to trig functions, namely that hypotenuse of one of the right triangles squared equals hypotenuse times the sine of the angle opposite the split squared for the other triangle plus the length squared of the first triangle. We can algebraically multiply out the parentheses so that one of the terms, as it is a straightforward multiplication, is simply the two factors squared, while the other term is more complicated. But if we are cautious in how we multiply out this term, we would see the result is the first term squared minus 2 times the first term times the second term plus the second term squared. After this, we rearrange the terms so that the subtraction does not sit awkwardly in the middle, and also so we can do the next step of noticing that one of the hypotenuses squared is a common factor, so we would isolate it. Although this isolation does not seem to simplify anything in a very useful manner, we can remember from how vectors work and how to break them into components that the magnitude times the sine squared of the angle plus the magnitude times the cosine squared of the angle equals the magnitude squared. It should become obvious that if we assume the magnitude is 1, that sine squared of angle plus cosine squared of angle equals 1. And we actually have that exact formula as one of our terms, so we use this identity to simplify things. And our final, most simplest result becomes one of the legs squared equals another leg squared plus the final leg squared minus 2 times the two legs besides the first one times the cosine of the angle opposite the first leg. And although this formula looks very tricky and awkward at first, the beauty of it is that you simply only need to know one of the angles and not two, like with the law of sines, in order to figure out any angle possible as long as you are working with a triangle. We can verify if this works for a right triangle too by plugging and playing it and seeing off the bat the cosine of 90, as the angle opposite the hypotenuse of a right triangle is always 90 degrees, is 0. owing to the fact that if a triangle had two 90 degrees, it would have no or zero length adjacent side. And so because cosine of 90 equals 0, we notice because it is multiplying by 2 times the other side lengths, it will cancel out and make those other factors 0 as well. So in conclusion, plugging in the law of cosines for a right triangle gives hypotenuse squared equals leg 1 squared plus leg 2 squared, which we already know as a basic fact of the Pythagorean theorem. Now that I've explained the law of sines and the law of cosines, as well as showed that the law of cosines is more convenient in terms of how many factors you have to know beforehand, I can transition away from trigonometry and toward non-geometric applications of algebra, such as explanations of how exponential functions or logarithms work, and why you would want to use them in games, such as for modeling the growth of a population of characters in a game, similar to how you would use it to model the population of people in real life, or the population of other organisms. Although, as you may already know from other schools, that trigonometry is more sophisticated than what I have taught, such as different trigonometric identities, or what a secant is. I believe those types of things are not necessary for applications in game design, as we generally only need to know how vectors work and how to solve for angles, so we will ignore all of the other details of trigonometry. By similar reasoning, I know that algebra is more complex than simply things like exponential functions or simple linear functions, but those are the most relevant to game design, so those, I believe, are the most worth investigating. Join me in the next tutorial where I first explain how an exponential function works, as in my opinion, they are more simpler than logarithms. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.